Hi, and welcome to this version of Teach and Read Science from home. Again, I'd much rather be in the classroom with you, but since we can't, this is what we're going to try to do today. I am today going to talk about tides, and we're going to talk about what tides are, what affect them, and how they affect the communities. We talked a lot about intertidal communities, which are the communities living on the rocky coasts, the sandy coast, and the mangrove, and how they are affected by the fact we have tides. And tide is a phenomenon that the water level will sometimes be higher and sometimes be lower during the day. And this can either be semi-diurnal, which is it'll change twice a day, or it can be diurnal, which means it changes once a day. We call this area the tidal range, which is the difference between the highest tide and the lowest tide. But as some of you might already know, the tidal range is not always the same. Sometimes we have very high tides, and sometimes the high tide is not as high. The same goes for the low tide. So we have this phenomenon that the water rises and lowers like a heartbeat all over the planet. How come? How can something as big as the ocean actually move up and down during the day? Well, this has to do with the fact of gravity. If this here is Earth, I know it's a badly drawn Earth, and we imagine that we have our oceans. Again, I am not actually drawing as a water ball all around us. Again, this is very exaggerated, but I hope you get it. Now, everything in our universe and the galaxy is affected by gravity. We pull at Earth and Earth pulls back at us. Of course, since Earth has a much higher mass than we do, Earth will pull a lot more on us than we will on Earth. That is why if I jump up, I'll fall down. That is Earth gravity pulling me. Well, Earth gravity, of course, is what keeps our oceans in place, but there are other things that pull at the oceans as well. And the biggest one is, of course, our neighbor star, the Sun. Now, the Sun will pull at the oceans, and this gravitational pull will make kind of a bubble. Another thing that will pull is the Moon. Of course, this is very badly drawn. It is not where the Moon and where the Sun is in reality, but it's just to give you a picture. Now, in this case here, if the Sun and the Moon are aligned, they both have a gravitational pull in this direction here. This will mean that the water here will be a little higher here, and it will be lower here. It will be lower here, but on the other side we'll get a bulge as well. So this of course means that here we'll have a high tide, and here we have a low tide. Now, since Earth is spinning, this high tide and low tide will then of course move around the planet as well. So it's the gravitational pull of the Sun and the Moon that gives us the tide. But the clever student will say, but Peter, the Sun and the Moon ain't always in the same place. This is here what we call a new moon, when the Sun and the Moon is right in the same line here. And if that happens, we will have what we call a spring tide. Because the Sun and the Moon is pulling in the same direction, the high tide will be high and the low tide will be low. This means our tidal range here will be very large. We'll have a large tidal range. But if we have the same thing here again, badly drawn Earth. We have the Sun here, and we have the moon in this position, as it will be sometimes? Well, of course we'll have a huge draw from the sun, as it is a very large object, so we'll have some tide here, but the tidal range will be much smaller than before, because of course the sun is pulling in this direction of the ocean, but the moon is pulling in the other direction. And when this happened here, when we have pull needs, we call the neap tide. And in this case here, the tidal range will be lower. Well, of course, there's one other option, and the clever student might, what will that happen then? What will happen when we have a full moon? When we have a full moon, the moon is on the opposite side here, all light up by the sun and full. In that case, we pull away this and this means the bulge will get bigger again on each side, and we will again then have a spring tide. So, the important thing here is that when the moon and the sun is on the same axis, we will have the spring tide, the highest tide. When the moon and the sun is on a different axis, we'll have the neap tide, the lowest tide. The gravitational pull of the sun and the moon is what gives us our tides, and the fact that the Earth then revolves is what gives us changing tides during the day. The position of the sun and the moon to the Earth affects how strong the tidal pull will be at this time. And as we'll talk about later, is then how the coast is will also affect how high the tide is, because at some places, even at spring tide, we might not get a huge tidal range, like half a meter, but other places will get up to like 12, even 14 meters. How can that be? Well, that will be the subject of my next video. But please remember, gravitational pull from the sun and the moon is what gives our tides. Thank you for being here with me today. Any questions, please put them here below the video or contact me on Teams or Swordplay. Thank you.